Hi there. My name is Daniel. I'm from Sydney, Australia, and I'm here to take you through my entry for the Google Gemini API Developer competition, and I'm calling it StoryMagic. So, StoryMagic is an Android app targeted at young kids to help explore their creativity and imagination through the power of short stories. Anyone with young kids knows that they can be quite enamored with digital devices. Whether it's streaming a show or playing a game, kids these days love to spend time in the digital realm. I wanted to build something for my own young kids that would be a beneficial use of time for them, but still keep them engaged and entertained. The app uses the power of the Gemini API and help of various Firebase services to generate engaging short stories where the child themselves are the protagonists, and it also gives them a chance to incorporate topics that they are interested in. Kids love the novelty of seeing themselves as a protagonist of a story and also choosing what the story is about. It's a surefire way to capture their attention and get them engaged. So let's take a closer look at the end user experience. The first steps to getting the app set up is to enter some basic details of the child that we want to create a story for. We feed the name, gender, and age of the child into Gemini to help generate short stories that are able to incorporate them in an age appropriate way. From this point on in the flow, I'm really targeting the kids themselves as the primary users, and that's helped shape some of the UX decisions that we'll see. So we allow the kids to choose from three different topics they'd like to see incorporated into the story. These are short, simple prompts that have an associated emoji to help provide context to younger users. I found my kids really enjoyed having the ability to customize the story, as it really is a novelty that's tailored to their desires. I wanted things to be as simple and whimsical as possible. You can see we've got a lot of playful animations, large, simple touch targets to make sure that when kids are using it themselves, they have a successful experience that they can get through. The home screen of the app is an animated vertical list of stories that have previously been generated. The UI of the app is 100% Jetpack composed, and you can see we're using it to great effect here. We're making heavy use of some custom scroll effects and transitions. We take a lot of advantage of some recently introduced Jetpack Compose APIs. For example, we're using some Canvas APIs to render realistic looking storybook covers for each story. The reading experience of the app lays out each page of the story with a full screen horizontally scrollable UI. In landscape and on larger tablet devices, we've gone a step further and we incorporate a more realistic page turn animation to really take advantage of the real estate we've got and also to reiterate the book metaphor that we're going for. My kids are right at the age where they're learning to read, and like any beginners, sometimes they get stuck. That's why the app takes advantage of the Android text to speech APIs to read the text of the page aloud. We provide UI cues to help the reader follow along and match the words that they're hearing match the sounds that they're hearing to the words they see on the page. Kids can also tap on an individual word to have it read out for those who want to challenge themselves but might need the odd bit of help on a word or two. Once my kids had generated a few stories, they were interested to share that out. They wanted to share it with their broader family just to let them know about it and get them engaged in the whole process as well. So that's why we built sharing as well. So each story has its own unique URL that that story can then be shared out however we want, and we use Firebase hosting to provide a web viewer with a similar UX to the app itself. That means that on the recipient end, if they're not on Android or not on a mobile device at all, they can still access the story just in a web browser. And for those that have the Android app, we have verified deep links to get the user straight into the app, into the story, and get the best experience possible. So let's take a look at where exactly Gemini fits in and how it makes this whole experience possible. There's three major components that make up StoryMagic. We've got the Android client app, the Firebase backends, and of course the Gemini API itself. We start off with the user saving the child's pertinent details that we'll use later to customize each story. These are basic things like name and age. We currently use Fire-based anonymous authentication to segregate users' data in the Firestore database and keep things secure and private. This also gives us a path in the future to introducing other authentication mechanisms in the app, like email and Google login, and it's a way to keep your accounts portable between devices or tablets or whatever you happen to want to use. So once those details are saved into a Firestore database, we send back an ID to the client. You can see this happening during the onboarding of the app. That's that first stage. This design lets users add multiple children in the app, so we can generate stories for each child without having to re-enter details over and over. And for anyone with multiple children, everyone has to have a turn, everything has to be even. So for me especially, this was a very important thing. After we've got that, we allow the user to create a story by providing the child ID and also by which topics they want to include in the story. The app allows users to pick up to 3 topics. They're server defined, and they also have the ability to type in their own ideas if they have something specific in mind as well. From here, we get into the real heart of the application. Our cloud function that's being called gathers all the child details and the story topics. We then take a response template to make sure we're getting structured output from Gemini, as well as a predefined prompt. We use the Google Gemini generative AI library to call through to the Gemini API. We're using the Gemini 1.5 Pro model at this stage. As we'll see later on, the extra latency of using the Pro model compared to the Flash model is not really that inhibitive to the overall user experience. So I kind of prioritize using the Pro model and getting more detailed output over just raw speed. So when we hit the Gemini API, we're asking it not just to generate the story text itself, but also a bunch of metadata that we'll use to fill out the app experience. So looking at the book cover, for example, we're generating the title of the book, obviously, an image description that we'll use later on to generate a cover. And we'll also generate a list of emoji that Gemini thinks best represents the story. And we'll get into what that's used for in a moment. Similarly, for each page, we're asking Gemini to generate a description of an image that could go along with the story text. And again, we'll use that later on. So once we get this first response from Gemini, we're doing a couple of things in the name of user experience. We save the story text and metadata into Firestore so that we've safely got a copy. And we then forward all that information back to the client immediately. So at this stage, we don't yet have our cover image or image for each page of the book generated. That can take some time. But we do have something that's readable. So together with some clever client-side user experience tricks, we're able to minimize the time that the users spend waiting, but still deliver a good experience. For example, the emoji that I mentioned earlier that we asked Gemini to generate for each story, we use that to generate a custom book cover on the client itself. So it's a nice looking pattern. It's still custom to the story, but it just means we're able to do it immediately without the user having to wait for an image to be rendered. So from here, the rest of the flow is happening asynchronously from the point of view of the user. So for each image that needs to be generated, for each page, we've got a Firestore trigger that listens out for the appropriate document changes, and we hit the Google ImageNet API. And this is currently using the Imagen 3.0 fast model to generate images for the pages. That was kind of a recent addition just in the last few weeks, and I found it's really performs really nicely, and it's definitely a big speed boost. So that's worked out really well for this project. So the API itself gives us back a base 64 representation of each image. So we take that, we transform it into a PNG that we can actually use. We save it into Firebase storage. We then generate a blur hash for each image. So for those unfamiliar, a blur hash is a small encoding of an image, which can be used to generate a blurry approximation of the original source image. So the advantage, or why I would want to do this, is This below hash is actually just a small string, very short, short enough to just be included as part of the metadata. And what that lets us do is render an approximation of the image before it's actually downloaded to the client. So there's a really nice UX trick that I like to use just to fill out the UI a bit more before the image is downloaded itself. Finally, as each image comes through, we update our Firestore database. And thanks to real-time syncing, which is such a staple in the Firebase Firestore world, we're able to immediately reflect that on the client. So we prioritize the story cover and pages earlier in the book as we're generating these images just to minimize the amount of waiting that the user has to do to get their full story experience. So just to reiterate, on top of the core experience being powered by Gemini, we're also using a whole suite of Google technologies to power StoryMagic. We've got cloud functions to provide the endpoints that the app interacts with. We take advantage of Firestore to persist all the user and story data, and also to get that real-time syncing I mentioned, so we can do things asynchronously and keep things fast. We use Firebase hosting to host the web story viewer, letting users share their favorite stories with others. We're relying on Firebase or anonymous auth to keep all data private. Of course, all the images are stored in Firebase storage, so that's gives us fast storage wherever you are in the world. And finally, of course, we're using a bunch of cutting edge APIs that are available in Jetpack Compose to power the animations and transitions through the app. So just a short mention of where the app can go from here. I'd love to incorporate some of the recently introduced AI generated live images that Google announced not long ago. I think it'd be even more engaging for young kids. So I'd love to get whitelisted for that. To get a more natural and engaging reading experience as well, there's also the Audio LM API, which Google provides, which looks really promising and performs really well. So it'd be great to integrate that. And both these things really lend themselves nicely to also integrating Chromecast and adding Chromecast support to the app. I have a bunch of Google screens, Google Chromecast devices in my house, so it'd be great to be able to show stories on those screens and make it a more communal experience. So adding support for that is on the shortlist as well. Thanks for listening. I hope you got to learn a little bit more about my project. The project is currently published for open testing on the Google Play Store. You can find a link to joining that open test in my submission. I hope you get the chance to try it out and find something you're able to enjoy in the app. Thanks.